Hello friends, today I will be taking BGAS Grade 2 Painting Inspector Chapter 1, that is corrosion. Corrosion. What is corrosion? Corrosion can be generally defined as degradation of metal by chemical or electrochemical means. From this definition, obviously two mechanisms are involved. First is electrical circuit, second is chemical reaction. So first is electrical circuit, second is the chemical reaction. In this photograph you can see this is fresh tube and this is corroded tube, that is degradation of material, and this cannot be used for further operation. Electrical circuit. In a corrosive circuit, the current is always a direct current, that is DC, direct current DC. It is conventionally thought that the current passes from positive to negative, from anode to cathode, from anode to cathode. In fact, the electrons are flowing in exactly the opposite direction from cathode to anode. For corrosion circuit, we require three things are needed, that is anode, cathode and electrolyte. So let me explain separately what is anode, what is cathode and what is electrolyte. Anode. An anode is a positive charged. It became positive charge because the atoms releases two electron each, thus causing imbalance between proton and electron, positive and negative charged unit. It's a passive state. The ion atom has 26 of each proton and electron. When two electrons are released, the atom still have 26 protons and only 24 electrons. In that state, the atom is now an ion, overall positive charge by 2 unit. Okay, ion can be a positive or negative charge particle, an atom or a group of atom. So what is cathode? Cathode is a negative charged area where more electron than needed. It is a passive state, electron released from anode. At the cathode, the electron enters into the electrolyte to passes back to anode. Electrolyte. An electrolyte is a substance which will conduct a current and be break down by it. So good example of electrolyte is a water, and which is very vast available and very effective. Other electrolyte can be an acid, alkali or salts. Okay. The hydroxyl is returned to anode through the electrode carrying the electrons. The corrosion triangle. So this is the corrosion triangle. You can see this is the corrosion triangle which is having anode, cathode and an electrolyte. The electron circuit, you can see the passes from anode to cathode. The corrosion circuit, cathode to anode via electrolytes. So this is called corrosion triangle. If a structure can be a cathode, it won't corrode. So we have generally for that only the cathodic protection technology has been introduced. The corrosion triangle shows three elements need for a corrosion, that is anode, cathode and electrolyte. If any one of this is removed from the triangle, corrosion cannot occur. The most commonly eliminated is electrolyte, placing a barrier between the electrolyte and the cathode and anode in the form of coating or painting system does this. If electrolyte is not in direct contact with anode or cathode, there won't be any circuit, and so corrosion will not occur. So the contact between anode and cathode from electrolytes to be removed by means of painting. The basic corrosion reaction as explained above occurs firmly slowly at the ambient temperature. In common with all chemical reactions, certain factor can increase the corrosion reaction rate. So let us see what are all that. First one is temperature of the steel. In common, the most metal is thermodynamic unstable. The hotter the steel, the faster the corrosion will occur. So corrosion rate will increase when the metal temperature is hotter. Second one is hygroscopic salt will attract water and dissolve in it when salts are present on the substrate. So what is substrate? The job is called substrate in BGAS. So present on this substrate and a coating is applied over them. When water is drawn through the film and the resulting solution build up a pressure under the film. Eventually the film forced to form a blister. So for easily example, this is the substrate or a job. When a salt is present over this job, either it may be a sulfate or a chloride, and when a paint is coating is applied over the salt, this salt will form. So this will build up a pressure on the coating, and form a pinhead size blister will form. It's a common painting defect. This blister are called osmotic or hygroscopic blister are defined as a pinhead size water filled blister, may be a sulfate or chloride are the two most common salts mainly formed in marine environment. Sulfates are formed found in industrial area and chloride are in marine area. So there may be a question, chloride are formed in marine area or industrial area, and sulfide in industrial area. Third is aerobic condition, presence of oxygen. By introducing oxygen into cathodic reaction, the number of hydroxyl ions doubles. That means double the number of ions will passivate, therefore double the corrosion rate. Presence of some type of bacteria on the metal surface, for example, sulfur reducing bacteria, better known as SRB, sulfur reducing bacteria, or metal eating microbes, MEM. And fifth one is acid and alkalis, and the sixth one is bimetallic contact or all bimetallic corrosion. What is bimetallic corrosion? Let us explain. Metals can be listed in order of the nobility. A noble metal is one which will not corrode. In descending order, the further down the list, the more reactive is in it. The degree of activity can be expressed as a potential in volts. In volts. The list can be a galvanic list, but when the free potential of the metal also known as electromotive force series or electrochemical series. So this is the table you can see galvanic list. This table can be called as galvanic list, electromotive force series or electrochemical series. You can see from the list, this is the high noble graphite is a high noble metal and having less corrosive, and the potential value is 0.25 volt, and magnesium is a low noble metal, more corrosive. So if you compare magnesium, zinc, aluminum, mild steel are more corrosive, but in case of graphite, titanium, silver are less corrosive. And this is the mill scale. This is the mill scale, which is having minus 0.45 volt. So let me explain what is mill scale. From the above list, it can be seen that mill scale is immediate above the steel on the galvanized list. This means that mill scale is a cathodic to steel, or if it is left on the steel surface, will accelerate the corrosion of the steel substrate. Mill scale is formed during rolling operation of the steel section, example RCS, RSA or RSJ. The oxide of the iron form very quickly at the temperature in excess of 580 degrees Celsius. So during formation of steel, if the oxide is formed, if the temperature is gone beyond 580 degree, mill scale will be formed in three forms, that Fe0 iron oxide, Fe304 and last is Fe203. The common three names of hematite, magnetite and hematite. These oxides are compressed during rolling operation to produce blue mill scale. The thickness of the mill scale vary from 25 to 100 microns, and it can be removed by any surface method, and mill scale will not reoccur. So with this corrosion